Okay, we'll get started. In this section we're going to be looking at 8a, which is cyclical motion. So cyclical motion is motion that repeats itself continuously. Motion. So some examples of that are down here. So for one, we have a planet's orbit. So if we have, again, a planet revolving around a sun or another planet, that's cyclical because it's repeating itself regularly, like it's regularly passing over the same points in a given amount of time. Another one would be a swinging pendulum, right? If we have like a ball on a string, that pendulum is going to go back and forth multiple times. It's going to be going over the same points over and over during the same or in the same amount of time. So that would be cyclical motion as well. And another one would be a flashing light. So again, flashing lights are typically going to happen at regular intervals, so it's going to be on, it's going to be off, and those are going to happen in predictable amounts of time. So those are some examples of cyclical motion. There are a lot of them, but those are some kind of examples to get you started thinking about it. So the next thing is there are two quantities that are associated with cyclical motion that we're going to talk about, and there's a little bit of math associated with them. So the first one is frequency. So the frequency, when C, with the little symbol lowercase f, so the frequency of cyclical motion measures how many cycles occur in a given amount of time, or how frequently something is happening. And the standard unit for that frequency is going to be hertz, abbreviated Hz, and that's going to talk about cycles per second. So for example, if something happens one cycle or one time, so one cycle or one time per second, we'd say that has a frequency of 1 Hz or 1 hertz. So that would be, right, its frequency. Again, if it happened 2 times a second, so if you said there were 2 cycles in 1 second, you would say that it has a frequency of 2 hertz instead. So again, hertz, standard unit for talking about how frequently something happens. The next quantity that's associated with cyclical motion is going to be the period. Yep. So the period, and it's going to have the symbol uppercase T because it's a time. It's going to measure how much time it takes the cycle to occur. So again, another way of saying that is what period of time does the cycle happen in. And again, the standard unit's seconds. So let's give an example. So like you think about this, okay, well, the sun rising. The sun rising. When does the sun reach its highest point in the sky? That happens once every 24 hours. So again, the period of the sun hitting its highest point in the sky is 24 hours. Right, that's the period. That's in hours, so we would normally express it with the standard metric unit seconds, so I have it written down here. So 24 hours, right, is the period, but in the standard metric units, it would be 86,400 seconds. So that would be the period. So just to give you kind of an example. And then the last kind of idea here is that, okay, frequency and period are both important, and they can be related by this equation. So frequency is 1 over uppercase T, so frequency is 1 over the period. Just important to keep in mind, because of math, we can just flip this around, right? We could just rearrange it slightly. So we know that this is true as well. We know that the period is 1 over the frequency, so we know that the inverse is true. So either of these two equations, they are the same thing, they're just rearranged slightly. So once you have one, you're able to get the other. So just to summarize quickly, cyclical motion, motion that repeats itself, lots of stuff would qualify as cyclical motion. The frequency, how frequently something happens with the standard unit hertz. The period, how long it takes something to happen with the standard unit seconds, and there is an equation that relates those two quantities. Okay, so let's move on. Let's see a problem about period, about frequency, and about cyclical motion. So here we go. We got a problem. So see if you could solve it out first before I go through it. So even if you just get part of it out, right? Even if you just get maybe the equation or write down your knowns and unknowns, you're able to solve one, but not all of them, just anything. Okay, so I'll go through now. So it's saying, okay, well, we have the following events. Identify if they qualify as cyclical motion, and then if they do, calculate their period and frequency in standard units. So let's start with A. So A, we have a heart beating 70 times per minute. That is pretty fast. So 70 times per minute, that's happening at a regular amount of time between each cycle or between each heartbeat. So yes, we'd say that's cyclical motion because the heartbeat's predictable, it's happening over and over. Yes, we would say that is cyclical motion. And we need to find the period or the frequency first, and then we can convert with the other using the equation. It's probably easiest to find frequency first because they say, oh, there's 70 times per minute, or there's 70 cycles in 1 minute, which is the same as saying, like, oh, okay, there's 70 cycles in 60 seconds, which is, if we just divide that out, that gives us 1.16 repeating, 1.16 repeating hertz, right, because hertz is the number of cycles per second. So that's the frequency right there. Now, to get the period, it's fairly straightforward. We just need to plug it into the equation, and we're going to use the period is 1 over the frequency. So that's pretty straightforward. So we just do 1 over the frequency, and we're going to get out the period. So the period is 0.86 seconds. And that makes sense, right? The 0.86 seconds, because it's 70 times a minute. So it's happening a little bit less than, or it takes a little bit less than a second for it to happen. So makes sense. So again, that's the first one, frequency and period for the heart beating. The next one is talking about the Olympics. So it's saying, okay, well, the Olympics is held annually, except for 1916, 1940, 1944, and 1960. I think that actually might be wrong. I think it was held in 1960. But regardless, so the Olympics is held regularly except for these couple dates. Is the Olympics cyclical? No, it is not, because it got canceled at like irregular dates, right? Because the number of years between 1916 and 40 is different from 40 to 44, right? So it's not getting canceled in regular intervals. It's not happening at regular times. There are these weird breaks in it. So we would not say that is cyclical. And the last one here, well, Saturday happens once per week. So that I think is fairly straightforward to say, yes, that is cyclical motion, right? 1 time per week, cyclical. So now we need to look and calculate the period and frequency. It is probably easiest to calculate the period first, because the period is 1 week. But we need that in seconds, technically, to get these standard units. So we have 1 week. 1 week is 7 days. 1 day is 24 hours. And then 1 hour is 3,600 seconds, which is basically 60 seconds in a minute, 60 minutes in an hour. If we do that out, we're going to get out what? It's a lot. It's 604,800 seconds. So 604 604,800 seconds is the period. This is t. And then again, to get the frequency, it's kind of the opposite of what we did before. So 1 over the period is going to give us the frequency. So we're going to get the 1 over 604,800. And that's going to give us a frequency. It's 1.65 times 10 to the negative 6 Hz, hertz. Yes. Again, so that makes sense. The period's huge, it's a lot of seconds, so it's not going to be happening very frequently. It's going to be happening very infrequently. Right? It's not even 1 hertz. It's some really small fraction of 1 hertz. Okay, so that's a good kind of example of these. Period, frequency, cyclical motion. So make sure you have these problems down. Make sure you have the notes down, and that is it for now.